Okay, welcome to Vector Queries with Vec1. Vec1 is a vector similarity search extension for SQLite. And we have here an early version of Vec1, 0.2. And we also have 1,128 dimension vectors from the best known public test set on the internet, SIFT1M, which is hosted there. Now, SIFT1M is good for demos because the dataset isn't too big, all told about 500 megabytes of data, so hopefully everything should run nice and quick for us. And there are the vectors in the base table. The same test set provides 10,000 sample query vectors for us to locate the best matches for in the dataset. So let's begin by loading one of those query vectors into shell tool variable q. And we will also turn on timers so we can see how long everything takes. Now, if we want to, we can do a vector similarity search directly on the base table. For this, Vec1 provides a scalar SQL function, Vec1 L2 distance, that calculates and returns the distance between two vectors. How the SQL query you can see there works is it calculates the distance between the query vector and each of the 1 million dataset vectors, sorts them in order of increasing distance, and returns the top 10. There they are. Now this takes about 200 milliseconds to run, so you're getting about 5 queries a second. So it is a little bit slow. And this is just the same query with a group concat wrapper to make it just a little bit easier to see the results. So that's our baseline. So now let's try with a Vec1 virtual table. Clear all that stuff away. And first of all, we create the virtual table. The leftmost column of a Vec1 table is the one that stores the vectors. You can add other columns to store metadata associated with the vector, but we don't need to do that today. Each row of the virtual table also has a unique row ID value to identify it. And once it's created, we can populate the Vec1 table using a regular insert command. Then, to query the table, we use it as a table-valued function. The first argument is the query vector, in our case q, and the second is the number of results you require. Like this. So great, right? Except that it wasn't actually any faster. The query still took around 200 milliseconds to run. And this is because Vec1 is still doing an exhaustive search of all the vectors. And that actually does have one advantage. It returns the true exact nearest neighbours every time. Now, it's currently considered impossible to provide this guarantee without an exhaustive search. So to speed this up, systems like Vec1 fall back to providing approximate nearest neighbours, where the results will usually be very good, but are not guaranteed to be the true nearest neighbours every time. In practice, most systems and users can't tell the difference, but it is a trade-off. So to switch to approximate nearest neighbour mode and speed things up, Vec1 needs to be configured with a trained model, which is basically a plan to compress and index the dataset vectors to make searching them faster. But before we do that, we'll configure Vec1 to use multiple threads. Training models and building vector indexes are both compute-heavy operations, so using multiple threads is quite worth it. You usually set this to the number of real cores the machine has. To create a model, you have to train on a set of vectors with a similar profile to those you will index. Usually this just means an arbitrarily chosen subset, but in our case, we have a dedicated set of 100,000 training vectors provided by the curators of SIFT1M stored in the Learn table. Training a model and having a virtual table use it to create an index are fundamentally separate operations. You can train a model on one machine and use it on another if you wish. But here, for convenience sake, we'll do it in a single SQL command. So the select Vec1 train subquery you can see up there is an aggregate that reads all the vectors from the Vec column of the Learn table and returns a blob value containing the model. The JSON object passed as the second argument to Vec1 train contains the model configuration parameters. Then the special insert command takes the model blob and hands it off to the virtual table, which uses it to build an index over its vectors. So let's run that. And there it is. Now, because these vectors are smallish, training and building the index is fast, less than 3.2 seconds wall clock time. But if you look at it closely, you can see it actually used over 40 seconds of CPU time. So it's lucky we configured threads. Now we can run our query again. And this time it's much better, less than 500 microseconds. But now we have another problem. The results aren't very good. Now, there is a fair bit of overlap with the exact results we can see above, but there are a few row IDs missing as well. Perhaps good enough sometimes, but that's not really what we wanted. Now, the standard solution is re-ranking. Re-ranking is a simple idea. It means that instead of reading 10 approximate matches from the index, as we just did, we'll read 100, calculate their exact distances from the query vector, and then return the best 10. With Vec1, you do this with a regular SQL order by clause, just like the one we used on the base table a few minutes ago. Like this. And there it is. With re-ranking, we now get the same results as the exhaustive search, the true nearest neighbours, but we get them in around 600 microseconds.